In this example, we're going to look at how to figure out whether the first derivative is positive or negative, and when the second derivative is positive or negative. Let f of x be defined by the graph below. Over which intervals is part A, f prime positive, part B, f prime negative, part C, f double prime positive, and part D, f double prime negative. Now before we start solving this, it's worth mentioning that you can answer the same kind of question not by thinking about derivatives, but by thinking about the graph increasing or decreasing, or being concave up or concave down. And so somebody could do a similar problem even if they didn't know calculus. Okay, let's start to solve this. Part A, we'll look at the graph, and we'll start by figuring out not directly where the graph is going up or down, but rather where it changes. That's where f prime is equal to 0. And I've marked 3 points on the graph where that happens, and those are the local maxes and local mins. You can see that those are the most important points because between them, the first derivative won't change. So for instance, between the first two red circles, we have that the slope is always positive, and I've highlighted that in red. Or to the right of the last circle, again the slope is always positive. Okay, so those are the points that matter, and exactly what matters about them is the x values. So you take each of those points and you trace straight up or down to hit the x-axis. I've marked those points with question marks, and then you read off those x values from the graph. So I got negative 0.75, positive 0.75, and 2. Those are the numbers we're going to use in our answers, those three numbers. Okay, here's how it looks. Part A. F prime is positive if x is between negative 0.75 and 0.75, or between 2 and 2.6. Now let me make a couple of comments about that answer. First, x is what matters here. I'm describing only the x values, not the y values. And the reason is because if you know something about x, then you know really something about the function. All you have to do is plug in the x value, and you can figure out what the y value is if you need. The second thing is that 2.6 that we used on the right-hand side. Now you might guess that the graph keeps going up to the right, but it's just a guess. All we know for sure is what we can see, and that graph we can only see up until we get to x equals 2.6. So that's why I stopped there. Now there is a more compact way to write this answer down. You can write down, instead of all these words like between and, you can write down just inequalities. So in that case, you put x in the middle with a less than sign on either side. In fact, there's an even more compact way to write it, using interval notation. So in that case, you don't even write down the x or the inequalities, you just write down the numbers, and then you put parentheses around them. The u in the middle means all of the numbers that we have on the left together with all of the numbers we have on the right. Okay, so that's our answer for part A. Part B is simply everything else that is not in our answer for part A. So if we look at the graph, the part that's going up we've already described, and everything else we would have the graph going down. So here's how it would look. F prime is negative if x is between negative 1.4 and negative 0.75, or between 0.75 and 2. And again, the negative 1.4 is simply where the graph ends. We can write this more compactly using inequalities, or even more compactly using interval notation. Now, if you compare our answers for parts A and B, you should see that each number got used twice. Once to mark the edge of where the first derivative is positive, and then once to mark the edge of where the first derivative is negative. Okay, so now it's time to turn to concavity. Here's the original graph again. And I am going to look at the same parts of the graph, but I'm going to be looking for different information. So I'm not going to mark the maxes and mins with a red circle. It turns out they don't play the same role for us here. But I am going to start by looking at the first minimum. I've highlighted it here in blue. And that minimum has the clearest concavity, or one of the spots where the clearest concavity is. The minimum has concave up behavior, and you can see this in a couple different ways. The graph is, in fact, curving up. The graph is also going up on both sides, and you can also say that the graph looks like a cup, right? Cup rhymes with up. Okay, so here's another spot that's clear on the graph. I've marked it in blue, the second low point on the graph, and again, that's concave up. In the middle, you have the maximum, and that's concave down. And you can remember down, down rhymes with frown. It also is, in fact, going down on both sides. And it's also curving down if you read it from left to right. So those are the three places where the concavity is clearest. And what I like to do to figure out where does the concavity change is I imagine extending each of those highlights, the blue and the green areas, I extend them until they meet in the middle. So here's what it looks like when I extend it a little bit. Okay, I made each area a little bit longer. They haven't quite met, but then I do it one more time, and you can see where they meet in the middle. And that meeting, those meeting points, that's where the concavity changes. So let me mark those with red. And again, we want to know the x values, so you trace straight up to the x-axis. I've got them marked with question marks, and then you read off those numbers, negative 0.4 and positive 1.5. Those will be the numbers we use in our answer. Okay, here's how it looks. So, f double prime is positive if x is between negative 0.4 and negative 0.4, or between 1.5 and 2.6. So this is the far left side of the graph and the far right side of the graph. Again, we can be more compact if we use inequalities, or we can be most compact if we use intervals. Now to think about when f double prime is negative, it's simply going to be everything else in the graph. And in this case, what that means is it's the middle of the graph. So, f double prime is negative between negative 0.4 and 1.5. Or we can write it with an inequality, or we can write it with an interval. And that's pretty much it. We can write all of our answers down using interval notation, and we can compare again that each number we found shows up twice. And here's what all four answers look like.